Hello everyone, our group is Maddie, Sequoia, and Mila, and our study is on observing secondary succession via post-hurricane recovery in Point Pleasant Park, Halifax.
Point Pleasant Park is a public park owned by Canada, located in Halifax, Nova Scotia, consisting of around 75 hectares of land in the unceded territory of the Mi'kmaq people. The park's forest type is primarily made up of Acadian species like the red spruce and the red maple, along with the ground and soil consisting of many different types of rock. Point Pleasant Park is important to the Mi'kmaq people because before the land was turned into a public park, it belonged to their community. The park holds both spiritual and cultural significance, and the Mi'kmaq Nation is known for their practices and respect for the land while focusing on sustainable land growth for thousands of years. Because of the urbanization done in the park in 1749, the park was challenged in facing a double negative. Because the urbanization not only had a negative effect on the ecosystem of the park, but also to the Indigenous people that have cared for the land long before us. And by doing such, we not only disrupt the balance that was made and cared for, but also negatively impact and disregard the relationship between land and the Mi'kmaq people. In 2003, the park was struck by Hurricane Juan, which caused large amounts of damage to the park, but it was said by researchers like Burley et al. That the damage from the hurricane could be beneficial and was actually a positive way for the park to reset its succession. This research is significant because by using the damage done by Hurricane Juan, Point Pleasant Park researchers have been given the opportunity to survey the park by recording the new growth in hopes of positive post-hurricane recovery management with help from field assessments and reviewing aerial photos of the land. This study focuses on answering proposed questions around total tree density and species richness in the park from the years 2004 to 2024, with the data gaps in 2005, 2007, 2016, and 2020 because of hurricanes and COVID-19. Our hypotheses are that total tree density, red spruce, and red maple densities in Point Pleasant Park will increase over time and recover from the 2003 Hurricane Juan, along with our hypothesis that species richness in Point Pleasant Park will increase over time and recover from 2003 Hurricane Juan damages.
When the data was collected for this study, sampling sites were randomly chosen from 30 locations within Point Pleasant Park that had similar elevations, topography, and pre-hurricane species composition. Subsections within each site were labeled as disturbed, with less than 20% canopy cover, or intact, with more than 80% canopy cover. 1 by 1 meter squares, evenly surrounded by a 10 by 10 meter square, were permanently marked at random inside each subsection, and monitored in the years following the destruction from the hurricane. Each year, the species of each plant at the sites were recorded and identified using local field guides. The number of each species present was then tallied up and later used as a metric. Plants were also classified as native or non-native. In order to ensure all species were recorded, each plot was visited repeatedly throughout the growing season of each year. The number of different species in each area was later counted to get the species richness metric, and the abundance of each species in each area was used to calculate the density of each species in each site. Linear regression analysis was used to measure overall forest community change, dominant species density change, and change in species richness due to its ability to easily and clearly show trends in discrete datasets.
The graph shows the change in total tree density per 400 meters square in Point Pleasant Park, Nova Scotia, from 2004 to 2024, with data gaps in the stated years. The data findings support our hypothesis that tree density in PPP has increased over time and will continue to recover from the 2003 Hurricane Juan. The recession line of the graph has a slope of 8.7 and an R2 value of 0.49. An R2 value of 0.49 means that about 49% of our tree density differences in PPP can be explained by time, which supports the research done in 2008 by Burley et al., saying that weather, like hurricanes, reset succession in parks, making room for new and stronger growth. The leftover percent of 51 tells us that there could be other factors involved, like storms and hurricanes. This can be seen by density fluctuations throughout the years, like in 2015, where we can see a large increase in density that drops after the 2003 Hurricane Matthew. Although hurricanes may cause damage to the land, the look of the torn apart area is often worse than the actual damage that was done ecologically. The study that was performed was to track the increases and decreases in total tree density in PPP after Hurricane Juan. Based on the collected data, PPP will experience secondary succession and is predicted to return to its pre-2003 hurricane conditions and reach its climax community. This is important because, as the data shows, if a disturbance and disaster were to happen, the environment could recover, which could help future research and conservation methods.
This data was collected and graphed to discover the effects on tree dominance after Hurricane Juan hit at Point Pleasant Park. This was done by measuring the post-hurricane densities of red spruce trees and red maples in 2004 through 2024. These densities were measured at 6 sites in Point Pleasant Park, Halifax, Nova Scotia, Canada. It was found that in the recovery from the hurricane, the red spruce showed a gradual increase in density in the 20 years following Hurricane Juan, though this R-squared value of 0.1228 is low, which points to high levels of variability. In the red maple, we see a steeper slope of 2.565. This shows a rapid increase in species density over the years after the hurricane. We must conclude that yes, the hurricane did have an effect on species dominance at Point Pleasant Park. Before Hurricane Juan, the red spruce was the dominant species, but after the hurricane hit, 70% of the trees were lost. In the following years, we see a shift in dominance from the red spruce to the red maple. The red maple becomes quite abundant. On average, from 2004 to 2024, around 5.5 red maples are seen for every red spruce. This is because the red maple has the ability to thrive after disturbances in the environment, such as this hurricane. This ability led to the dominance seen now. However, in the absence of future disturbances, the red spruce may gradually reobtain dominance over the red maple as the forest moves towards its climax community.
Years following the devastation caused by Hurricane Juan, species richness has significantly increased. The recession line of the graph has a positive slope of 0.53 and an R-squared value of 0.61. Since this R-squared value is greater than 0.6, it is considered statistically significant in ecology and shows that the majority of the population follows the upward trend that is visible in Figure 3. This supports our hypothesis that species richness would be initially low after the hurricane and increase over time. Species richness is a vital contributor to high levels of biodiversity, which is a key factor in protecting ecosystems that are valuable to humans. Point Pleasant Park is an important Halifax green space that provides many visiting Haligonians with mental and physical health benefits. Increased biodiversity helps increase Point Pleasant's resilience, preserving access to this valuable service. This study was performed to observe the increase or decrease of species richness in the area after a massive disruption, monitoring this aspect of secondary succession in Point Pleasant Park. At each of the replicate sites, researchers documented which species of flora were present, and then used this species identity information to determine species richness, creating a metric that could be compared over several years' worth of data. Over the last 20 years, species richness has significantly increased. Many plant species present in these areas are now secondary successors, and either colonized or recolonized these areas in the years since the hurricane. Species richness increased over time as the disturbed ecosystem diversified, and additional species were able to disperse into the changed habitat. As the tested sites move closer to achieving a climax community, we predict that the species richness will follow its current trend and continue to climb as the ecosystem diversifies. Once the climax community is reached, however, species richness will likely increase at a slower rate, since the community will become more stable and previously established species will have a competitive advantage over newcomers.
Point Pleasant Park is an urban park, and this can cause effects in succession due to human activity. For example, the paths throughout the park, built by humans, can affect the dispersal of seeds and spores, and can cause a disturbance in overall forest growth. Pollution as well can have very harmful effects on the forest environment and can reduce growth rate, increase susceptibility to pests and disease, and have negative effects on soil health, and much more. An examination of the species density and richness recorded at multiple sites in Point Pleasant Park showed the recovery of the forest as it moves to its climax community in the 20 years following the destruction of Hurricane Juan. Data observed shows the following. The forest has changed following the destruction caused by Hurricane Juan. The forest is recovering, but has not yet reached its climax community. Dominance has shifted from the red spruce to the red maple post-hurricane. Species richness has been climbing rapidly with the ecosystem's recovery. These observations suggest that while the hurricane's destruction in Point Pleasant Park changed the forest community, it is recovering, just has not yet reached its climax community. Assuming the environment is allowed to follow its natural course with no further disruptions, this forest will continue to recover and grow even closer to its climax. As this approaches, there may be a shift in species dominance back to the red spruce. Species richness will continue to rise as the ecosystem diversifies until a stabilization is met at its climax, and the forest will reach a recovery similar to that of the forest there before. There is an indigenous practice of burning. This is where small controlled fires would be intentionally set to mimic the natural fire cycle and promote healthy forest regeneration, as well as reduce the fuel load for possibly much larger wildfires. A takeaway from this practice is that while the ecosystem was destroyed, it is able to regrow and become stronger for it.
Our group would like to give thanks to the past student data collectors from 2004 to 2024 years of the course, along with the instructors Christine and Allison, and our lab TA Abigail. Point Pleasant Park is in the unceded territory of the Mi'kmaq people. Therefore, we would also like to give our acknowledgments to the Mi'kmaq community who have been looking after the land for thousands of years, along with giving Point Pleasant Park its original name, Amtukati.